Hi, Mr. King here. We're going to look at some trig expression simplifications in this tutorial. These are some examples from a practice sheet that we gave out in class. The first one is tan squared theta plus 1 divided by 1 plus cotangent squared theta. And this one, hopefully you'll recognize quickly, has some very nice quantities in it. Tan squared theta plus 1 is equal to secant squared theta. That's an identity that we know. It's a version of the Pythagorean trig identity. So let's replace that with secant squared theta. And then 1 plus cotangent squared theta, well, that is cosecant squared theta. So we're going to replace that right away. The next thing that we can do is we can replace secant squared theta with 1 over cosine squared theta. Remember your reciprocal functions. And then cosecant squared theta, that's 1 over sine squared theta. And at this point, we can take this and we can multiply the top and bottom, that is the numerator and denominator, by sine squared theta. And that yields sine squared theta over cosine squared theta, which is tangent squared theta. And we are done. 3 has secant theta, tan theta, cosine theta. It's a series of products. And in this case, this looks reasonably straightforward as these things go. We're going to replace secant theta with 1 over cosine of theta. We're going to replace tangent with sine of theta over cosine of theta. And of course, we've got a cosine of theta right there. Well, this cosine of theta will divide this cosine of theta nicely, and I think we can see that we've got sine of theta over cosine of theta remaining, which is tangent of theta, and we are done. Number 5, we have 1 minus cosine squared theta divided by sine squared theta. Well, if we rearrange the Pythagorean trig identity, we see that 1 minus cosine squared theta is sine squared theta. So this one goes very quickly once we know that. We replace the numerator with sine squared theta. We keep the denominator the same, and sine squared theta divided by itself is 1, and we are done. In number 7, we also have some identities disguised, you might say. I think we can see that tan squared theta, if we need to write it that way, would be secant squared theta minus 1. 1 plus cotangent squared theta is cosecant squared theta. So cosecant squared theta minus 1 is actually cotangent squared theta. And we're going to make this substitution now. So we're going to have tangent squared theta times cotangent squared theta. And now we're going to rewrite sine squared, excuse me, that's a mistake. Let's fix that. We're going to replace tangent squared theta with sine squared theta over cosine squared theta. And we're going to replace cotangent squared theta with cosine squared theta over sine squared theta. And when we look at these two fractions, we see that they are indeed reciprocals. And so they multiply to give us the value 1, and we are done. In number 9, we again have a trig identity looking at us. If we realize 1 minus cosine squared theta is sine squared theta. So we will replace it immediately. And so we will get cosine squared theta divided by sine squared theta, which is cotangent squared theta. And we are done. Moving up to the next one, this one looks like it might be a little bit trickier. Don't see any obvious trig identities per se, but tangent sine over cosine and secant is 1 over cosine. So let's replace tangent with sine of theta over cosine of theta. And let's replace secant with 1 over cosine of theta. Now, in this form, we can see that we could multiply everything by cosine in the numerator and denominator. And when we do that, it will leave us with the following. Well, let me write it out a little more explicitly this time. Some of you may not be quite as comfortable with working with fractions like this. So each of these cosines divides to 0. And this cosine has to distribute. Remember, a division symbol is a grouping symbol, so this numerator is grouped. So this cosine is going to distribute to this part. Excuse me. And so that will give us a sine of theta, because that cosine divides that cosine of theta. Excuse me. And then this cosine multiplies that 1, and so we get cosine of theta right here. And so this is simplified to sine of theta plus cosine of theta. And we are done. Here's our last example. And once again, cosine squared theta minus 1 can be seen to be negative sine squared theta. And sine squared theta minus 1 is seen to be negative cosine squared theta. And these are both a rearrangement of the Pythagorean trig identity. So we will make those substitutions as a first step. And so we'll get negative sine squared theta divided by negative cosine squared theta. Now negative over negative is positive, and then sine over cosine is tangent. So this is tangent squared theta. And we have simplified number 13. I hope these 5-6 examples or so have been helpful to you. See you soon. Take care.